So we are going one step further, checking out a few different graphs and how they look depending on what information is presented to us. So let's get going. I've already filled the next page in, so go ahead and hit pause. When you finish copying all this down, then hit play and I'll be explaining. Okay, so here I've tried to fill in this table with all of the information just to show you what all's going on, but it, obviously it's gotten a little jam-packed. The first pair of shoes is 20, and then each pair after that is being cut in half. So the first pair, we start out at total of $40. Second pair, we add 40 plus 20. That's half of 40. Makes 60. Then on the third pair, we have 40 plus 20 plus 10. 10 is half of 20. Makes a total cost of 70. 40 plus 20 plus 10 plus 5 for the fourth pair. And then on the fifth pair, the 5 gets cut in half to 250. Now it did get jam-packed, but you can see that totals $77.50. So here are your X numbers, and here is the total cost of those shoes. So the total cost depends on the number of pairs I buy. And we're going to fill in the rest of this. So I'm going to hit pause again. So I'll let you copy this down. You want to go ahead and hit pause again. Then I'll fill in this graph. I'll try to blow it up where I can be a little more accurate on this iPad. Pause. Alright, so as you can see here, we have labeled the graph. I've used the right labels. Okay. I've made it to scale, putting the cost going up, the total cost going up the left-hand side, and we've just gone every other hash mark there. Then the same down here, we've gone every other hash mark as far as the number of our shoes. And normally I would have written this 1, 2, 3, 4 underneath it, but it's just getting a little cramped, so you get the idea. Then I plot my points. If I didn't buy any shoes, I didn't spend any money, so there's 0. One shoe cost $40. You can look at your ordered pairs that you just wrote right above. 2 pairs cost 60, 70, 75, 77.50. So you can see that the curve is flattening out. And I guess if this continues, pretty much the shoe department would start paying you to take shoes. But anyway, just a joke there. And so if you're not finished filling in the graph, then hit pause. Take a couple of seconds to fill in your blanks here on the second page, example 2. Alright, so hopefully you have copied this down, and I have just thrown in the graph that you would see according to this problem. A balloon is inflated with air. That's showing that the volume is increasing as that balloon gets blown up and up and up and up. As more air is pumped into the balloon, the volume increases until it finally bursts. So bang, right there, you get the pop, and your volume goes to 0. Again, this label should be underneath it. We're labeling the Y part of the coordinate plane, and it would be labeled amount of air. Going up the side would be the volume. We don't have any specified units. So you're just showing the idea of inflation and then dropping to 0. So that's another type of graph you might run into. And you're going to want to hit pause now. Well, maybe you didn't really need to pause. Anyway, after looking at this question a little closer, we are talking about how Lucy jogs up a hill at a steady pace. Then she runs down the hill and picks up her speed. She starts running faster. Up the hill was a steady pace. Then when she gets down the hill, she's running faster and faster. Which graph below accurately represents this situation? Well, you're not speeding up and then slowing down, so it's not that one. You are not increasing in speed and then running at a steady pace. That's not what the question said. You are running along at a steady pace and then you start sprinting down the other side. So graph 1 would be the best choice. And let's fill this in and hit pause. We'll be referring to the graphs at the bottom of the page. I'll try to sketch one in. So you probably want to hit pause and copy this stuff down. I'm going to jot in the graph that you would be seeing there on the bottom of your page. And it would look something like this. Okay, that's graph number 2. So pause it and get everything written down so you can listen to me. Okay, so the reason that I went ahead and did the difference in the heights right here is to see that it's speeding up. It's falling faster and faster and faster, and that's just the nature of gravity. You'll learn if you're taking physics or physical science. And that's represented by a steeper and steeper curve down until it hits the ground at 0. So that's why we would use this particular graph. Starting it at a height, falling down faster and faster. Alright, and we'll move on. Alright, hit pause and jot this down. Now, what you need to think about here is, in 1983, and all the way up until 1985, the cost of the stamp was 22 cents. And if you'll remember how we talked about when we're graphing things, the solid dot means it includes that price. Well, this price would be at 22, and it stays level until you get to 1985. And then you see the open circle because we're not including 1985. In 1985, it jumped up to 25 cents. And that went all the way till 1987. Then you see the open circle jump up, got a solid circle. Actually, that one would go from 85 through 89 because, well, actually to 1991 because it stayed at 25 cents for 3 consecutive years. Then we would write another solid dot up here at 29 and show that it stayed level from 91 up until 1993 and so forth. So you see this stair-step motion when you have something that costs something for a while and then it jumps up. And we use the proper notation. The dot includes that year. The open circle does not include that year. It just shows where you stopped and then jumped up. Alright, hope that makes sense. And fill things in. Well, I guess that's the last example. So show me some work and show me that you tried some of these assignments. You really should be able to complete them. And then you would be able to do other homework in my class when you come in tomorrow. Goodbye.